So for this video, we want to compute this improper integral. And notice it's definitely improper because it's going off to infinity. So it's a type 1 improper integral. And we also have to make sure everything is good with the function that we're integrating. So note that this function is discontinuous at the point x is equal to 1, but we're integrating from 2 to infinity. So this is just a type 1 improper integral, and we're just going to compute it. And whenever I say something like evaluate, this is really sort of shorthand for tell me what this is equal to if the integral converges. If the integral doesn't converge, then explain why it doesn't converge. So given the definition of improper integrals, the integral from 2 to positive infinity of dx over x minus 1 to the 3/2, this is equal to the limit as r goes to positive infinity of the integral 2 to r. So I'm replacing my infinity limit with the r dx over x minus 1 to the 3/2. Okay, and this is equal to the limit as r goes to infinity, the integral 2 to r, and I'm going to write this in the numerator, so x minus 1 to the minus 3/2 dx. Okay, now you don't have to do u substitution, or you don't have to explicitly do u substitution to solve this problem, but I'm just going to do a little quick u sub here, and if you can do it in your head, that's completely fine. I won't always write out the u sub for stuff like this. So u is equal to x minus 1, du is equal to dx. And so now over here, this is the limit as r goes to infinity. Okay, I need to change my integral bounds. So the lower one here is 2, but u is equal to x minus 1. So this is going to be 2 minus 1, which is 1. And this one is going to be r minus 1. And now we're going to have u to the minus 3/2 du. This is equal to the limit as r goes to positive infinity. Okay, let me take the antiderivative here. So what's the rule? I add 1 to the exponent and divide by the new exponent. So I'm going to add 1 to the exponent. Minus 3/2 plus 1 gives me minus 1/2, and I divide by minus 1/2. And I evaluate this from 1 to r minus 1. Again, the limit we haven't really done anything with yet, but we're going to start to think about it now. So this is the limit as r goes to infinity. Okay, and so what I have here, I have this minus sign and the 1/2. So this is going to be minus 2. And when I plug in r minus 1, I'm going to get minus 2. So u to the minus 1/2 is 1 over u to the 1/2. So I'm going to get minus 2 over r minus 1 to the 1/2. And then minus, when I plug in my 1, I'm going to get minus 2 over 1 to the 1/2. Okay, and I can kind of switch the minus signs around here and pull out the 2. So this is going to be 2 times the limit as r goes to infinity. Okay, so I'm factoring out the 2. I've got a minus times minus, so this is just going to be 1, and then minus 1 over r minus 1 to the 1/2. Okay, and so what's going to happen here, as r goes to infinity, r minus 1 goes to infinity, so the square root of r minus 1 goes to infinity, and this term here goes to 0, and overall, this is just equal to 2. Okay, so again, for this problem, we had to first note whether or not we were going to have a discontinuity at some finite number. We realized that for this function, there was a discontinuity at 1, but we're only integrating from 2 to infinity, so the discontinuity isn't over the range of values that we're integrating, but we are integrating to infinity, and so by definition, this is what the integral is, and then we just evaluated it like this.